Okay, here's the situation. M&Ms, they say that 20% of the plain M&Ms are orange. Now, we're going to take a large bag of plain M&Ms and pull out 8 candies and let X equal the number of orange candies you get. There you go. So, what do we do for letter A? Explain why X is a binomial random variable. Well, how would you do that? Well, you got to check your bins, right? Bins. Is it binary? Well, it's either orange or it's not orange, right? Yes or no? Okay. There's that. Orange or not. And is it independent? Well, one candy that you pull out is not going to affect the next candy that you pull out. Now, but we are not replacing it. Okay, so what we got to do is we got to assume that, let's see, there's 8 candies getting pulled out, and we're going to assume that there's over 80 candies in the bag, or in our whole population. And the number is we choose 8 candies. That was set beforehand. And then the probability, we're going to say, is roughly the same because of the number of candies we have in the bag. So bins is A-OK. Let's look at the letter B is find and interpret the expected value. So how do we figure out the average number? So the way we figure out the average number that we're going to get is n times p. So it would be 8 times 0.2. So, and the answer to that is going to be 1.6. Let's see. And then, so what that means is if we did this experiment over and over and over again, on average, we would expect to have about 1.6 orange M&Ms if we took the average of doing it many, many, many times. Okay. And let's see, standard deviation of this random variable. How do we do that one? Oh, it's a square root of the number times the probability times 1 minus the probability, which is 0.8. What do we get for that number? And that equals 1.1.13. So, on average, we're going to get 1.6, give or take about 1, orange candy. There you go. Let's look at the next one. So the next one, here we go. Would you be surprised if none of the candies were orange? Compute an appropriate probability to support your answer. Okay, so let's see. The probability, let's see. We should write it like this, right? The probability that our random variable is going to be equal to 0, right? Well, we have 8 candies, and we actually get none that are orange. Sorry, New York accent. Let's see. And then what are we going to do? We're going to say 0.2, right? And we got none. And then 0.8, and we got 8. So that's how we calculate the probability. Let's see what we get. So if you want to try this one, remember you press 8, and then you go into math, press the button that says math on your calculator over to probability, and it's NCR and 0. And you only get 1 for that. There's only one way to arrange that. And then you probably know that 0.2 raised to the 0 power is also 1. And then you multiply that by 0.8 raised to the 8th power. So anyway, all that stuff gives us the probability that we get 0 is going to be 0.167. I could also go into second vars and all the way down to, I think it's letter A, binomial PDF. That is the fact that we get exactly 0 right there. Okay, that's letter A. What about letter B? So letter B says, how surprising would it be to get 5 or more orange candies? So we have to do this, I think. So here's B, and we're going to say it is 8, choose 5, and we're going to have 0.2, and we got 5 orange candies, and we got 3 that were not. And we're going to do this again, except this time we got 6 orange candies. So 8, choose 6, and 0.2 times that gives us, we got 6 orange candies, and then 2 that were not orange, like that. And I'm going to go dot, dot, dot to 8, choose 8, right? Okay, so we have to do the probability for 5, 6, 7, and 8. So I kind of indicate this, and then a lot of times in the answer book they say, using technology. Okay, so that says, okay, I know what the formula is. I'm not going to do all that stuff. I'm going to use technology, in other words, the calculator. So what would you do for that? Well, instead of doing binomial PDF 4 times and adding them all together, I could use binomial CDF like that and say, well, we could just figure out that it's 4 or less all in one thing and then subtract it from 1. Okay, so like this. So it looks like that. So it's 1 minus binomial CDF would give us the same thing as if we added all these together. So let me do that. And that gives us point 0104. What does that mean in context? So we only have really a 1% chance of this happening. So 5 or more orange, when the probability is only 20%. So that does seem a little odd, don't you think? I get 8 candies and 5 or more of them are orange. That would seem a little bit weird, which is what this indicates, weirdness, only 1% of the time. Okay, there's that.